quick background. I worked at the Subsidence District for about 10 years. Subsidence District is the groundwater regulator for Harris County, Galveston County, and Fort Bend County. Very similar to Lone Star Groundwater District. They have subsidence in their name because they're really what spurred most of their conversion from groundwater to surface water was as water levels were dropping in the hydrostatic pressure in the aquifer, you were getting subsidence, land surface subsidence, over 10 feet along the ship channel. And when you have a multi-billion-dollar oil and gas or chemical facility along the ship channel, and you're only at 20 feet above sea level, and you lose half of that, that's serious business. So worked there for many years. I was their general counsel, but we had a small shop, about 15 to 17 employees, and so we got to do planning, all sorts of technical. I got to utilize my civil engineering degree. It was a lot of fun, very good experience, and it served me well here. So let me tell you sort of the rest of the story. So Paul laid out for you the challenges we're facing in Montgomery County with water supply, specifically groundwater levels, because we are right now 100% reliant on groundwater. And the problem with water level declines is cost, all about the money. Our job as utilities is to be sure that we deliver enough water to meet your demands at the lowest cost possible. Cost is the driver. And I'll get to a slide in a little while where we'll talk about long-term regional water planning and how we look at cost and lining up the sources of supply that we use to meet our long-term water needs. But let me tell you real quick who and what the River Authority is, because many of you may not have heard of the San Jacinto River Authority. We've been a very sleepy little entity. Our main office is on the dam at Lake Conroe. Been around over 75 years, but it's good to stay out of the press, so that's what we try to do. But our primary job, as with the other 24 or so river authorities in the state of Texas, is long-term water resource planning and development. So you look 50 to 100 years into the future, you decide how much water are we going to need within our area, which for river authorities generally are river basins. So we cover the entire San Jacinto River Basin. You look 50 to 100 years and you make sure you're going to have enough water to meet all the needs, municipal, agricultural, industrial, whatever they may be. And if you don't have enough, you develop more. You build reservoirs, you build canals, you build pipelines, you pump it from where they have it to where you don't. I mean, whatever the strategy is, you get those things in the queue and get them ready for development. In addition to that core function of river authorities, we also, because we're regional in nature, generally will sort of evolve to fill some other needs that are requested of us within our basin. So in this area for the San Jacinto River Authority, one of the very first undertakings we had was in our East Harris County and our Highlands Division. So this is actually Lake Houston. This is the dam at Lake Houston. And right here on that eastern shoreline, we have a pump station. We deliver raw water from Lake Houston to industries in the ship channel. Exxon's our biggest customer. Chevron is our second largest customer. We actually had a pump station there before Lake Houston existed. We were on the riverbank, essentially, and we had to enter into a very complicated agreement with the city of Houston back in the 40s and 50s to move that pump station so that they could build Lake Houston. So that was our entry into the water business. After that, around the late 60s and early 70s, our next two operations came into being. That was our operation at Lake Conroe and here in the Woodlands. They were sort of going on simultaneously, but I'll hit Lake Conroe first. And during the drought of the 50s, obviously the state water planners at the time said, we can't let this happen again. We need to have more strategies in place to deal with drought. And there was a reservoir building boom, and Lake Conroe was one of the reservoirs that resulted from that. We constructed the Lake Conroe Reservoir. It was a partnership with the city of Houston. They paid 2/3 of the cost, but they asked the River Authority to do the construction. The city was also involved in getting Lake Houston built, getting Lake Livingston built. So I sort of surmised that at the time they said, look, let's let somebody else build that one. We'll pay for it, we'll own the water, but we've got enough irons on the fire. So the River Authority built that. 2/3 of the water, though, is owned by the city of Houston because they paid for 2/3 of the cost. So that was our second primary operation. Now, obviously, it was built for long-term water supply. Here in the Woodlands, it was a little different. We're a regional entity, governmental entity. We have the ability to do regional projects. We were asked by the developer of the Woodlands if we would be the wholesale water provider for this area. Now, if you live here, which I'm sure most of you do, you don't write your monthly bill to the San Jacinto River Authority, it's to a MUD. And Jim will tell you during his talk a lot more about the relationship and how that evolved and the contracts that are in place and how we structure that. But I'll just suffice to say we're the wholesaler. We operate the water wells, the wastewater plants, the water towers, the transmission part of the system, the retail MUDs do the distribution. Then our final division, I'm going to go into in more detail in a minute. Just touch on the fact that we have a 7-member board. We're a governmental entity, just like a state agency, but we don't cover the entire state. We just cover the river basin that we're in. Our board is appointed by the governor. That's one of the Woodlands wastewater treatment plants. And then this is our GRP and aerial photo of the dam at Lake Conroe. I'm going to go into a lot of detail on that. So let's talk about the GRP division. Basically, GRP division stands for Groundwater Reduction Plan Division. We were trying to come up with a name that was very creative. Lone Star Groundwater District requires that all of the large users in the county do a groundwater reduction plan. Turn it in to Lone Star for approval. And we said, well, let's just call the operation that. We racked our brains and didn't get very creative about the naming, but that's where we ended up. The goal of this new entity, or this new enterprise for the River Authority, was to create a county-wide solution to meet Lone Star's regulations. So Lone Star is requiring all the users in the county to cut their use of groundwater by 30%. That's a major, major cutback. That's more than you can accomplish just by going out and asking people to use water a little more wisely. So our board of directors directed our staff to come up with a solution that would be available to any utility in the county, because with water, moving water over a long distance is very, very expensive. So if you happen to be a city or a utility that's close to your source of water, you're in great shape. If you happen to be 60 or 90 miles away from the water supply, your costs are going to be a lot more. And so they didn't want to create a situation in Montgomery County where location became a huge driver in water costs. We wanted to create a solution that would put anyone who wanted to join it, wasn't mandatory, but anyone who wanted to become a part of it, we could do it at the lowest possible cost with the least amount of infrastructure, but basically treat all these large volume users on a cost neutral basis. And the way we accomplished that was this. One way to convert, hypothetically, each of those yellow dots, if that's a MUD or a city, one way to convert them is to build a pipeline and deliver 30% of their needs straight to their doorstep. Extraordinarily expensive, because as I said, moving water is very expensive. Instead, what Lone Star allows us to do is take a few of those entities, over-convert them. So say they convert, in my little hypothetical here, to 60% surface water, more than they're required to by Lone Star. But if all 10 of those entities have signed a contract together to share the cost, there's a lot less cost in building those pipelines than in this previous slide. But they share the cost across all 10. And the Lone Star District treats all 10 of them as being in compliance. The aquifer cares a little bit where the pumpage occurs. If we could distribute all the pumpage in Montgomery County uniformly across the entire county, we would have a lot fewer areas with decline than what we're seeing today. But it doesn't work that way. We use the water where we live. But the Lone Star District will treat all 10 of those entities as being in compliance. It saves a lot of money. So that's what we're doing. That's the plan that we've been implementing for the last, basically, well, since I moved here and started with the River Authority about 7 years ago. So what are we building? Because we're now to the point where we are at 91% complete on this project, and I'm very happy to announce there are no roads in the Woodlands that Let me tell you, this time last year with the Ironman coming, we were in full red alert mode trying to stay out of the way for that, and this year I don't have to have anything to do with it, so we're very happy. But what are we building? Let's talk about that. First, we have to build a surface water plant. Lake Conroe was built for water supply, but we haven't used it for water supply yet. So now we will begin using it for water supply. It'll be a 30 million gallon per day plant. Cost almost $200 million. We're at 91% complete and we'll be finished in a couple of months. And I'm going to run through real quick just a few pictures of the status of the plant. Here's an aerial photo. These are the raw water pumps that sit out over Lake Conroe. And I'll just sort of step you through the system. Pre-treatment system, you mix it with a little lime and let the big particles fall out of the water. Push it through some strainers, and then here's the heart of the system. It is a membrane plant, microfiltration plant. It's pretty cutting edge, it's fairly sophisticated. The goal here was to build a system that we can deal with whatever contaminant might come our way. Now right now Lake Conroe is one of the only water bodies in this entire region that is not impaired from bacteria. We have a very excellent water quality in Lake Conroe, but two things happen all the time. More people move here, you have the risk that the water quality might deteriorate. We're trying to prevent that. You also have ongoing tightening of regulatory restrictions. So we expect restrictions to become tighter over time, not less tight. And so we've built a plant that basically we feel like we can handle any requirement that may come our way. Another shot of the membranes. After that, we'll run the water through a giant carbon filter. So I have a slide somewhere else later on of a Brita filter or something you might have in your refrigerator. Essentially, a lot of those are a carbon filter. That will be a carbon filter. There's about 10 of those, like swimming pools full of granular activated carbon. And this is a polishing step. It wasn't required. This was really a taste, odor, aesthetics thing. And then there's some water chemistry reasons we did it too. So the pipe gallery underneath those swimming pools. And then here's where the action occurs. Once it's been cleaned, it goes through this high-service pump station. We'll pump it from Lake Conroe down Fish Creek Thoroughfare, through the Woodlands, all the way to Rayford Road Mud. And also in the conference. Electrical gear for the pumps. We recycle all of these cleaning systems. Every time you filter something, you're left with what you filtered out. We basically, some of it's turned to dirt, and the water that's squeezed out is returned to the plant, treated again. Everything's recycled. Have no liquid waste, just some solid waste that comes off the plant. And it'll have its own water quality laboratory, constant, continual water quality testing, not just at the plant, but at every delivery point where we're delivering water. Pipeline system looks like this, and as I mentioned, we've got a line that heads east into Conroe, and then we've got this line down Fish Creek that goes through the Woodlands and gets over to Oak Ridge and Shenandoah and Rayford Road, or not Shenandoah, Oak Ridge, Rayford Road and Southern Mud. That's almost $150 million, and we're 91% complete on that also. And then just a few shots. Not very exciting. As the engineers say, dig hole, insert pipe, cover up hole. Except for creeks, railroads, highways, major intersections, and then there's some tunneling involved. That was a pretty interesting process. And then, of course, here in the Woodlands, we had places where there was no room in the ditch to put a water line, especially a 48 or 36-inch water line. So in some areas we agreed to go out under the pavement, not the best place for us, but the only places where we could, that's where we could get it done, so that's what we had to do. This is the pit for the tunnel under the waterway. That was about a 60-foot deep pit. It was a very exciting project for the engineers. They were kind of all a water nerd. Well, the engineers loved this kind of thing. It was very exciting. This was the tunnel under State Highway, well, that says under I-45. There's a very similar tunnel under State Highway 105. Not the job I want to have. I'm a little claustrophobic, but it reminds me of the Great Escape, so I always like to include that picture. Standpipe, we had to have pressure control in this system is extraordinarily important. It'll run standard 130 to 170 psi. Sometimes higher, sometimes lower, so there's a couple of places where you've got to be prepared to deal with pressure surges, and this is one of those. We're running fiber optic cable along the entire length so that we can monitor delivery. We'll meter all the flows, we'll meter the water levels in all the tanks, make sure it doesn't turn on a dime. It's kind of like steering the Titanic. You've got to make slow, steady turns. I should have picked a different vessel, actually. I'll work on that for the next time. So the fiber optic was just a natural. You're digging a hole, you put in pipe and a cable, and then cover up the hole. And at every receiving location, which there are 17 receiving locations, we have metering facilities and computers and things that will monitor the flows. Now, we've had to shift our message. If you live in the Woodlands, I hope you've gotten our message either in the mail or in your bill or via emails or something. We have been putting out information about this program for at least 5 years. Part of it was to get prepared for construction and to basically assure people, yeah, it's going to be messy, but it's going to be fast. We're going to get in here, out of here, and we'll be out of your way. Well, now our message is shifting to water quality because we'll be drinking this starting late summer. It'll be blended. It won't be 100% surface water. It'll be a blend of groundwater and surface water, and that blend will change from summer to winter. But we basically planned with 3 different major things going on with water quality. Number 1, meet all the regulations. That's just, you have to do that. This second tier, we wanted to make sure the water was compatible with pipes in your house. And I've got a slide about that in a minute. And then on top of that, we just would like people not to complain about the taste and odor. We want it to be seamless. We don't want you to notice any difference. The filtration system, and I won't spend too much time on this, but the little dot there, that's the pore size of our microfilters. And then some of these are just other things to give you an example. Giardia cyst, Cryptosporidium cyst. I mean, these are some of the bad things you want to take out of the water. And so we have, like I said, a very robust system that will provide a very, very high treatment level. But another complication that isn't always thought about is what will this water do when it hits your water system? Because we're blending with a different chemistry. This groundwater that we're pumping and using today, it's a different alkalinity, it's a different pH, it's just everything's slightly different about it. Your pipes in your house may have some lime scale. I mean, you may have a softener on your home, you may not. We've got moderate hardness in Montgomery County typically. Well, when that surface water starts to come through, if we didn't do something to make it more compatible, it would basically clean your pipes. It will begin to dissolve that scale. Might not taste quite the way it tastes at the plant because it's flushing out your pipes in the process. So we actually add some minerals to the water so that the chemistry is more similar to the groundwater you have today. And we ran loop tests. We took pipes out of places in the Woodlands and we ran water through it to make sure we could deliver water that's going to be compatible. It's a detail. I have to mention it because I'm bragging on our engineers. They thought of some things that aren't always thought of. And there's my picture of the granular activated carbon. They come in giant bags. We've got like 800 tons of it stacked up on a road outside the plant right now, ready to be put in. So one of the questions I was asked to cover was, what about lake level? Now I don't get that question when I'm in the Woodlands as frequently as I do when I'm speaking around Lake Conroe, I'm sure you can imagine. But I was asked to talk about it, so I'm happy to. And I've used a lot of different methods to cover this question. I've used different graphics. I've gotten tremendously detailed and down into the weeds of modeling. I've backed out of the weeds and given kind of the high-level overview. Different things work better for different people, so I'll just touch on a few. First of all, on average, since Lake Conroe was constructed, we spill on average 7 feet of water per year. Lake fills up, and we're like we are today. We are spilling water today. We're about 3 inches over full, water coming over the dam. But on average, 7 feet of water spills out in a year. We will use 1 foot of water per year, starting this year. We'll begin using 1 foot per year for drinking water supply. So in 10 years, if the population continues to grow, we would probably need another foot of water per year. The most we're allowed to take out of Lake Conroe by our state of Texas permit is 4 feet per year. That's the maximum amount we're allowed to use from Lake Conroe. That is its yield. So let me show you that in a few different ways, and if you'll hit play. I don't show this west of I-35, but this is what we're doing today. Let's see if it'll run. You have to click that play. There you go. So these are Tainer gates. They open from the bottom. You lift the gate. You can see spillover coming over the top side. I mean, we are full. But that's a happy sound to me. I'm happy to be full. I usually tell people we have a happy zone. If we're within 2 feet, 201 feet above sea level, within 2 feet below or 2 feet above, everybody's happy. If I'm outside of that zone, people begin to get up. So we're spilling today, and that's a good thing. But let's look at the last 7 years. This is the water levels and what they've done since 2010. I'm going to bring up the next one. So I added a few more years. I'm going to put the annual rainfalls in there just because I thought this was interesting. Our average rainfall is about 48 inches per year. Our average rainfall for this county, for this part of Texas. And so you can see in 49, 42, we're hovering right around 201. And you get your normal sea, so it's dry. You get a dry, hot summer, level's going to go down a foot. You get a wet winter, you pop back up. And the lake responds pretty quickly to these large rainfall events. But I'm glad that Dr. Niels Gammon put that slide that showed the red dot for 2011, and you saw how it wasn't even on the same scale with the rest of the dry years in terms of how hot and dry it was. That's what we had, 20 inches in 2010 and 24 inches in 2011. This is off the charts dry. This is an extraordinarily dry period. And you can see the lake dropped 8 feet, 8.5 feet. It's the lowest we've ever been. The city of Houston took about 2.5 feet of water for use in Lake Houston, because that's their backup emergency supply. So they did call on water for a couple of months during that period. And then we've eking our way back up to normal, 46 inches, 40 inches, 46 inches last year. So we're experiencing a lot better conditions, and you can see that's reflected. Water levels pop back up. We didn't fill until 2014. Finally, now we're back to kind of our normal operations, which is sometimes the gates are closed and a lot of times the gates are open, letting water out. So that's just to give you an idea of how the lake responds to rainfalls and drought events. Now, I'm going to show you a graphic. This is the graph I use when I'm answering this lake level question. We had a study done by Freese and Nichols engineers, and the green line is what the lake level has been for the last 40 years. Now, I did this study back in 2009, so I don't have the drought. And that's not because I was trying to avoid the drought, it's just that's when we did the study. And we spent a lot of money doing this study, and I just haven't had a desire to update it. But because it still illustrates the point. This is what the levels were with essentially no use of Lake Conroe. Entergy uses a little bit of water for their power plant near Willis, but we've had very little demand placed on terms of water supply. If we were using 1 foot per year for this entire period, that's 1 inch a month, which is what we intend to use, 1 inch a month. That blue line is what the lake level would have been over that 40-year period. And I had given this speech 100 times without this graphic, and I tried to explain taking 1 inch a month from the reservoir when you're spilling on average 7 feet a year, you're just not going to see that until you go into a long drought. When you go into a long drought, where you're not getting the rainfall every month, then you can basically just subtract 1 inch per month off of whatever it was before, and that's where you'll be. So you can see 98, 99, 2000, there was a little, I made this term up, it doesn't mean anything. I call it a green drought. There was enough rain that your lawn kind of stayed green, but those of us in the water supply business were fretting because we weren't getting enough runoff to fill up our reservoirs. And that's kind of what we had. And so you could see the lake ended up at about 197, 4 feet low. We would have been maybe 195, a couple of feet lower if we had been using 1 inch a month during that period. So that's the concept. That's kind of how lakes work now. 1 foot per year is not all we're going to use. This is after 2035. 2025, we estimate that we'll need 2 feet a year. After 2035, we estimate we'll need 3 feet per year. And in 2045, we would need the maximum 4 feet per year. And obviously, if I'm taking 4 inches per month, you're going to see greater fluctuation in lake level. But it's not what I hear periodically from time to time. When we turn the plant on, the level's going to drop 10 feet and never going to come back. Lakes just don't work that way. There will be an impact, but it won't kind of be normal. And this is assuming we meet all of the future demand for water in this county with surface water. It's kind of a worst case. There are other water supplies that we'll be using, so let's talk about those quickly. We have studied a number of supplies because, as I mentioned earlier, our job is to meet the water demand at the lowest possible cost. It's all about the cost. Conservation is very, very inexpensive water. It's just hard to get people to do it because it requires us to take a little action in how we utilize water. And so it's something you do always. We'll always be working on conservation. You'll never hear that message stop. We do drought contingency plans. So these second strategies, you want to make the sources you have today last as long as possible. So as that water level in Lake Conroe begins to drop, we have plans in place that also apply to our customers. So all the 95 or 96 utilities in Montgomery County that joined in our countywide plan, when we tell them, okay guys, the lake's 4 feet low, it's time to turn on your drought contingency plan and you've got to cut all your usage back 10%, whatever the percentages are. That is to help the lake and our water supplies last longer, make it through that drought, and then when it starts to rain again, we can relax some of those standards. Reuse, we do a lot of reuse here in the Woodlands. I'm happy to report that the golf course at the resort conference center has been on treated wastewater effluent for decades, long time. And we are working with the new golf course owners to expand that, to provide treated wastewater to more courses. We're also studying the Catahoula Aquifer. And I'll show you a slide in a minute with a little more detail on the Catahoula, but the point of it is there are places in Montgomery County where that water's fresh, there are places where it's brackish, and there's places where it's very salty. And the cost to use it at each of those locations is dramatically different. So that has to factor into your cost when you're deciding what to use. And then obviously we are always on the lookout for more sources of surface water. Lake Livingston is the next most economical place to go for additional surface water for our particular area. So we have a contract in place with Trinity River Authority for another 50,000 acre-feet of water out of Lake Livingston for the time when that's needed for Montgomery County, which it'll be a while. We have a lot of water at Lake Conroe we haven't used yet. Paul showed you this slide. The point I want to make with this one, really, I'll just go straight to this one. This is a map, and it's been revised over time. It shows, in general, where that Catahoula Aquifer is fresh, northwest part of the county, very salty, south part of the county, and then there's sort of this transitional area where you'll have brackish groundwater in those zones. Now, we have a partnership with the city of Willis right here. They have 2 Catahoula wells, and the River Authority's GRP customers, all of our 90 customers, we got together, and Willis is one of those customers, and they decided, yeah, we'll enter into a contract with Willis, we'll provide them some financial backing to drill these wells into the Catahoula, because any conversion off of fresh groundwater that any of our participants do benefits all the participants. That's how the contracts work. So it was everyone's best interest for Willis to do this. Interesting thing though, their well on the east side of 45 is pumping about 1,300 to 1,400 parts per million. It's not as fresh as they thought it would be. And on the west side of 45, it's just under 1,000, around 900 parts per million. So this blue line is supposed to be the 1,000 parts per million line. That now we know is a little bit tighter loop than what we maybe suspected before. So we're learning about the Catahoula. The San Jacinto River Authority was asked to do a test well. So down here in the south part of the county, behind that Woodlands Walmart on Woodlands Parkway, you know where that near 2978, we drilled a test hole 4,000 feet down at the base of the Catahoula. We took water samples at 2 different levels. Down at the base, there's a real thick sand down at the bottom of the Catahoula, very prolific, would produce a lot of water if we were to produce it, but it was very salty, like 41,000 parts per million, saltier than the Gulf Coast. And so we also pulled from a thinner sand at around 2,300 feet. And it wasn't a very productive sand. I don't know if we could have made a well from it if we had even wanted to, but it was about 2,500 parts per million. So still well above the 1,000. And again, it's all about the cost. Everything we do is, in fact, let's have you more. Yeah. If you look at the Region H water plan for Montgomery County in this region, those are basically the strategies that are lined up for Montgomery County. So for the next 50 to 100 years, Lake Conroe is not on this list, but we're using Lake Conroe. Groundwater, Lake Conroe, Lake Livingston, Catahoula, reuse, conservation, drought contingency, some fresh, some brackish, all of that's basically in reuse. I've mentioned that. That's where we'll be getting our water for the next 50 years. So how do you decide which one to go for first? The cheapest one. every single time. Fresh groundwater is the cheapest one. You want to maximize that first. You want to use as much fresh groundwater from the Jasper, Evangeline, Chico, wherever you can get it, as you can before you go to that next more expensive source. It's not a complicated process. And basically every other factor, environmental, bugs, bunnies, whatever kind of cost, power, radioactivity in the water, you can take every different challenge you run into, you convert it to dollars, you work it into your cost, and you line those strategies up, and you take the cheapest ones first. That's basically how it works. So I think that's all I've got. Thank you for your time.